Hello everyone, welcome to my video project for limits for calculus class. Now let's look at an example of a rational function. For our example, we have the limit as x approaches 2, x to the third minus 8 over x minus 2. Now before we look at this example, any analytical or calculus technique, let's first look at it in Desmos in our graph. So first you can see that the function is undefined at x equals 2 because of division by 0. We can also see graphically that the limit does exist at 2 as we approach it from the right side and left side. We can see that the limit is 12. Now let's look at a calculus technique of how to solve this rational function. Our first step would be to factor the x to the third minus 8, and we would do that in the format of a to the third minus b to the third equals a minus b, a squared plus ab plus b squared, making it as follows: x minus 2, x squared plus 2x plus 4 over x minus 2. Now we can go ahead and simplify that further and see that our denominator can cancel out from x minus 2 and x minus 2, leaving us with x squared plus 2x plus 4. Now our second step is to use substitution of our limit of 2. So we would substitute our factored equation and factor in our 2. 2 squared plus 2 times 2 plus 4 equals 12, which can be confirmed again on our graph. Now looking at a calculus technique in a table of values in reference to our graph, we would choose two values approaching from the right and two values approaching from the left, giving us the y-axis, the y values. By doing so, we can confirm that our limit is undefined because our limits are not equal. They are not equivalent, meaning that our limit is truly undefined, as our graph can confirm. Thank you, everyone. Have a great day.